Thank you so much, sir. Heading towards our last technical session. The chair for this session will be Professor Dr. Shahid, and he is co-chaired by Saman Shahid. Professor Dr. Shahid is working as professor at National University of Computer and Emerging Sciences, Pakistan. He did his PhD in Hydraulic and Water Resources Engineering from Delft University of Technology, Netherlands. Please, sir.
Thank you very much. Can you listen me?
Yes, sir.
Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent, the most merciful. I am Dr. Shahid from NESPAK FAST, and in this session, my co-chair is Dr. Samar. She is associate professor, also from NESPAK FAST. I will welcome heartily our honorable guest, Dr. Muhammad Riazul Mustafa from Malaysia, and all respected presenters.
Sorry for interruption, sir.
Technical session. Okay.
Sorry for interruption, sir. Dr. Razaul Mustafa is not available right now. I think whenever he is available, we will let you know. And
okay, thank you very much. Dr. Razaul Mustafa is not available. We will go forward, and I will invite the Mr. Tayyab, who is from NESPAK Karachi, and he is going to present management of surface water resources to mitigate the water stress in Karachi. Ji, Mr. Tayyab, over to you. Please present, share your slides.
Ji, thank you very much, sir. Can you hear me, please?
Ji.
Okay, please let me set my PowerPoint.
Please share your presentation.
Can you see my presentation?
Not yet. Not yet. Please share again.
Still not visible?
Not. Please share
can
again.
From moderator side, can you please start my presentation? It's already with the team.
Now it is visible.
Okay.
Muhammad Tayyab, it is visible. Please present.
Today, I would be sharing my thoughts regarding management of surface water resources to mitigate the water stress in Karachi. Karachi is the largest, most populous city and the economic backbone of Pakistan, but unfortunately is presently facing the worst water crisis of the history. In this presentation, I would shed some light on national and regional water profiles, various sources of water available in Karachi and potential available in them. Moreover, a water management approach shall also be proposed in view of the estimated water needs, and the presentation shall be concluded with some recommendations on the findings of various performed analysis. Pakistan derives its water availability largely from rain, snow, and glacier melt, and runoff from summer and winter rainfalls. The variability of precipitation and river flows is marked by unique temporal variability that makes the resource management quite complex in Pakistan. River flows are generally limited in Rabi season, whereas their magnitudes is increased by almost 5 times in Kharif season. Total median annual flows from both eastern and western rivers are around 142 to 145 MAF. The availability in river flows during droughts has given rise to water crises and fuels interprovincial water conflicts. As the graph shows that irrigation water is by far the largest consumer of available flows in Pakistan. Pakistan, this is very alarming graph. The situation, the historic water availability situation along with population growth, the data presents that Pakistan touched the water stress line in 1990 and crossed the water scarcity line in 2005. Experts says that if this situation persists, Pakistan is likely to face the acute water shortage or a drought-like situation near 2040. Researchers predict that Pakistan is on its way of becoming the most water-stressed country in region by year 2040. If no imminent steps are taken to mitigate this water stress, no person in Pakistan, whether from north with its more than 5,000 glaciers or from the south with its hyper desert, will be immune to this water scarcity. Per capita design life storage capacity available at the moment in Pakistan is around 121 cubic meter, which is only higher than that of Ethiopia. USA houses the largest capacity of 6,000 cubic meter per person, followed by Australia and China. When compared with storage capacity of 900 days, just Colorado River in USA, Pakistan stands with a storage capacity of mere 30 days. Population growth and urbanization are the main reasons behind this crisis. The issue has also been exacerbated by climate change, poorly managed water, and lack of political will to deal with the crisis. Indus River via Kalri Bagar feeder. KB feeder, known as KB feeder KBFU, is the right bank canal of taking from Kotri Barrage, is the main source of water to Karachi at the moment, and that this canal also meets the irrigation needs of Thatha region. There are some of contributions from Hub Dam to meet the Karachi water needs, along with very small percentage of groundwater sources due to its not very good quality. Some of the water sources development works undertaken over the period of last 1.5 centuries are shown in the presentation. Water transmitted from Karachi via Indus River at Kotri Barrage is stored in Kinjar Lake. The wet season is just for 3 to 4 months, and the water, the excess flows available during that wet season are stored at Kinjar Lake for ensuring consistent supplies of water year round. Life storage capacity of the lake at present is 0.4 MAF. There are some nalas outfalling into the lake, but flows from those nalas are quite erratic and unreliable because they are some sort of fill torrents. Hence, KB feeder or Indus River is the only main source of water into the Kinjar Lake and Karachi at the moment. Presently, there are 2 outlets at Kinjar Lake. One is used to supply water to the Karachi, and the other is used to occasionally meet the irrigation needs of Thatha region. Cumulatively, from various sources at present, authorities managed to provide approximately 665 mgd water against a demand of 1200 mgd. Hence, there is a shortfall of 535 mgd at the moment. Moreover, the estimates suggest that out of this 535 mgd, there are 35% there are 35% losses in terms of transmission and water theft, etc. Hence, the available water drops to just 433 mgd. Recent projections suggest that Karachi's population will grow by 30% by 2030. Hence, increased pressure on demand side is imminent. Since Kinjar Lake is the main water management infrastructure in the system, hence water balance at Kinjar Lake has been studied. There are 6 major components of the water balance that have been studied. There are inflow that is coming from KB feeder canal, and there are outfalls, and definitely, yes, due to very high temperature rates, there are evaporation losses as well. Flow series at key structures have been developed to analyze the historic flow magnitude and water balance at Kinjar Lake. The pattern of flows being received at various structures has been shown in the slide. Flow series at KB feeder upper, the water being fed into the lake, and irrigation needs of Thatha. These 3 series are presented in the slide. KB feeder upper is designed at 250 cumics or 9100 Q6, whereas the data shows that it has never been operated to its design discharge due to its capacity constraints. There are The three flow series have been presented to you, and it can be seen that the maximum flow that to date has been fed into the KB feeder is around 175 MF, 175 cubics. The availability of high flows for a very short duration of time asks for efficient management of available resources, as it is shown in the graph that high flows are available from June through September or end of September only. K4 project has been designed to supply additional 650 mgd water to Karachi in two phases of development. During very first phase of development, 260 mgd of water shall be provided to Karachi, whereas this supply would be increased to 650 mgd in second phase of development. Therefore, the lake operation has been carried out to assess its capacity and inflows requirement to augment these, to meet these requirements of 650 mgd in two different phases of development. The operation has been carried using historic data of last 15 years, and it can be seen that for additional demand of 260 mgd, there are certain shortages in the system towards the end of each dry year, and system with its present flow inflows is unable to meet any additional demand. Therefore, additional inflows in the system are indispensable. The proposed approach suggests the action plan for managing additional flows and storage depletion pattern of the lake to ensure uninterrupted supply of water to Karachi. Since it has been established that additional flows to the existing system are indispensable, the most feasible option would be the utilization of excess flood flows that are available in Indus River during wet period, divert those inflows at tap those excess flood flows at Kotri Barrage and divert those inflows into KB feeder upper system, then store the excess flows in Kinjer Lake to be stored and relied upon year round. KB feeder upper has been proposed to be restored to its design capacity along with its lining for carrying additional flood flows. Different scenarios have been developed, as we have already seen that present system inflows are not capable to meet any additional demand. Hence, KB feeder upper has been revamped and lined. Scenario 2 discusses the effect of lining. The water saved from lining would be fed into the lake, whereas in scenario 3, additional inflows, additional water available in flood supplies at Kotli Barrage has been diverted via KB feeder upper by operating it on its design discharge and storing that water into Kinjal Lake.
Sorry for interruption, Mr. Tayyab. You are going to be short of time. Please finish it in within 2 minutes.
Okay, sir. Water availability downstream Kotri has been studied, and analysis of flows suggests that flows have always been plentiful during wet season, as we are at present losing around 29 mf of water in almost every year during the wet season. Hence, the wastages at Kotri have been analyzed and diverted into the Kinjal Lake, and these are findings of the operation. The operation in present situation suggests that the system cannot meet any further requirement at its present operation. Hence, additional flows have been diverted into the lake by lining KB feeder upper. The water saved from lining has been fed into the lake, and again, the results shows that still system is unable to meet any additional demands. In scenario 3, additional flows diverted from Kotri and stored into the lake has shown very promising results. The operation suggests that all the demands for 260 and 650 mgd have been met. Though there are some shortages for 650 mgd, but those minor shortages can be handled by internal management of the system. Moving towards conclusions, the analysis of the data suggests that flows have always been plentiful during the flood season. The average annual flows being wasted into the sea are of the magnitude of around 29 mf. Revamping KB feeder upper to its design and diverting additional flows would enable the system to meet the demand of 260 mgd, whereas occasional shortages of 650 mgd can be internally managed by the Sindh government. Optimizing the water needs and proper water pricing is very essential on demand side management. A changed and improved cropping pattern on the face of prevailing waterlogging and water stress scenario shall do a great favor. First-hand side information suggests, first-hand side data suggests that the system suffers substantial losses in terms of water theft and transmission losses, etc. Therefore, authorities should make maximum effort to moderate such losses in irrigation and domestic supplies. Thank you very much. Thank you.
Thank you, Mr. Tayyab, for nice presentation about the mitigation, the water stress in Karachi. But I have one comment. Just you have mentioned about the K4 project. I am little worried about that pace on which it is going, and I think it is difficult to finish in this year. You have mentioned about that it will be completed in this year.
Yes, sir. The
Yes.
pace is quite low. That's why I think the project has been handed over to WAPDA. Some of the infrastructure has already been completed, but yes, you are right, it would take some time.
Thank you very much, Mr. Tayyab,
Thank you.
for nice thought.